Right, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2019, and let's have a look at question 7. So this whole question is about the Cantor set. So we have a closed line segment from 0 to 1, that's from here to here. The first three steps in the construction of the Cantor set are shown. So step 1 involves removing the open middle third of the line segment 0 to 1, leaving two closed lines. So we've taken out this segment here, which is 1/3 of the line segment. So we're left with this from 0 to 1/3, and then from 2/3 to 3/3, or just 1, is left. Now you just continue that on, continue doing that. You're left with this line segment here, which you take 1/3 of this out. So you're left with 0 to 1/9, 2/9, and 3/9. This here would be 6/9, which is 2/3, 7/9, 8/9, and then 9/9 out to here, and so on. You keep, wherever you've got a line segment left, you just keep taking out 1/3 of each of the line segments, and the points that are left will always remain in the Cantor set. So this point here, 0, will always be in the Cantor set. This 1/3 will always be in the Cantor set. This 2/3 here will always be in the Cantor set, and so on. 1 will always be in the Cantor set. 1/9 will always be in the Cantor set. Now, in part A here, we have to complete the table below to show the lengths of the line segments removed at each step for the first 5 steps. Give your answer as fractions. Okay, so we can see here the first two are done for us. We have our line segment 0 to 1 here, and we took out 1/3, so 1/3 goes out here. Now we have these two line segments here, and we took out 1/3 of 1/3, so we took out 1/3 of 1/3, which is equal to 1/9, and we had two of these, so that means we took out 2/9. So in step 2 we took out 2/9. Now what about step 3 then? Well, we have 1/9 here, and we took out 1/3 of 1/9, so that's 1/27. How many of those have we got? Well, we got one of them here, one of them here, one of them here, here, and here. So we have 4 of these 1/27ths to take out. So here we will be taking out 4 27ths. Now the next one then is in step 4, which we don't have here. So if you, I'll just draw it here, and we'll just have a quick look at how that might work. Let's take 0 to 1/27. So let's pretend it's this length here. So this is 0, and this is 1/27 here. We're going to take out 1/3, so we're going to take out 1/3 here. We're going to take out this bit here. So this will be 0, and this is 1/27 here, so we've got to take out 1/3 of 1/27. So what we're going to do is take out 1/3 of 1/27. That'll give us 1/81. Many of those have we got? Well, we got 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 of those 81s, 8 of these 81s. Okay, so what about step 5 then? Now remember, we have 8 of these, 1, 2, 3, 4, 5, 6, 7, 8 here. So underneath here then we should have 16 line segments. So in step 4 here, in step 4 we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 of these line segments here, and what we're going to do is take 1/3 of each of those. So again, it's just simply going to be 1/3 of each of these. Now remember, each of these is 1/81 in length, so we got to take 1/81 times 1/3, and that will give us 1 over 243. 243. How many of them have we got? We've got 2, 4, 6, 8, 10, 12, 14, 16. We have 16 of them, so we'll have a total length of 16 over 243. And that's it really. That's all we were asked to do, the total length removed at each step. Okay, so let's look at the next section then. Actually, I might just move this up a little bit, give myself some room. Now, let's see, here we have, let's see, what are we asked to do? We're asked to find the total length of all the line segments removed from the initial line segment of length 1 unit after a finite number of steps in the process. Find the total length of all the line segments removed. Well, if we look at what we have up here, again, I'll just move this up a little bit. So these are the lengths removed here. Find the total length of all the line segments removed from the initial line segment for n number of steps. Okay, so if we have a look at the total lengths removed at each step, we've got 1/3, we have 1/3, we've got 2/9, we've got 4/27, we've got 8 81s, and we've got 16 243s, and so on. Now this here actually represents a geometric sequence, and what we've got to do is find the total length of all the line segments removed. So this is going to be an SN, and our formula for the sum of a geometric sequence is a times 1 minus or to the power of n over 1 minus or. Now in our particular geometric sequence here, our a is 1/3, our first term here is 1/3, and what are we doing to each term each time? Well, we're multiplying by 2 on the top, so our numerator is multiplied by 2, 2 ones are 2, 2 2 is 4, 2 4 is 8, and so on. So it's going to be 2 on the top, and on the bottom we're multiplying by 3, 3 3 is 9, 3 9 is 27, and so on. So our or is just simply 2/3. So let's just work this out. This should give us the sum of all of these lengths that are being removed. So let's see, we have a, which is 1 over 3. We have 1 minus our or, which is 2/3, and that's the power of n. Underneath then we've just got 1 minus our or, which is 2/3. Okay, so let's just simplify this a little bit. So you can see here we have 1/3 on the top, and actually what we end up with on the bottom is also 1/3. 1 minus 2/3 is just 1/3. So you can see here that that will divide by that, and we're just left with 1 minus 2/3 to the power of n. So this is our Sn. This will be the sum of all the lengths removed. Find the total length of all the line segments removed from the initial line segment of length 1 after a finite n number of steps in the process. Now we could check this out. Let's see. Let's take, you're not required to do this, but let's take the first 3 numbers here. These are the lengths that are actually removed at each step. So if you take 1/3 and you add 2/9, and then you add 4 over 27. I'm just quickly doing this on my calculator here, so it's 4 over 27. That gives you 19 over 27. So if we add those, we get 19 over 27. Let's just try our formula. We want S3, the first three steps here. That will be 1 minus 2/3 to the power of 3. So that will give us 1 minus 2 2's, 4 4's are 8, 2 3's 9's 9's 27. This would be, if you like, 27 over 27, that's 1, minus 8 over 27. So that will give us 8 from 27 is 19. So it does actually work. We get 19 over 27. So we got it by just simply adding the first three terms using our calculator and then using our little formula here. We also get 19 over 27. So it seems to work out okay. Okay, so let's go again then. Again, I'm going to have to move this up a little bit. Okay, so in this particular case we have to find the total length removed from the initial line segment after an infinite number of steps in the process. Okay, after an infinite number of steps in the process. Well, look, I think if you were to continue removing line segments indefinitely for an infinite number of times, the total length that you're going to remove is going to be 1. So let's just see, does that actually work out mathematically? So really what we're looking for here is the sum to infinity, the sum to infinity of the lengths that are removed. So that's just a over 1 minus or, a over 1 minus or. So in our case, a is, again, we're looking at this sequence here, this sequence of numbers here. These are the lengths that are removed each time. So our a, again, is 1/3, and our or, we're multiplying each one by 2/3. So in this particular case, we get 1/3 divided by 1 minus 2/3 is 1/3. So we do actually get 1. So the sum to infinity here is just 1. So that's the total length removed from the initial line segment after an infinite number of steps in the process. So if you continuously, indefinitely, into infinity, continuously take out line segments, the total length that you're going to take out will be 1. Okay, so let's have a look at the next bit then. Now, in this case, we have to complete the table below to identify the endpoints labeled in the diagram. Give your answer as fractions. So again, if we look at our initial diagram here, there are various endpoints here. So we have an endpoint here which is a. Now that's just going to be 2/3 because it's the same underneath here as well. Okay, we have to identify E, and there's a B here, C, D, and F. So let's have a look at these just from here, and then I'll fill them in the table in a minute. So if we have a look at A here first of all, if you look here, we took out 1/3 from the middle. So this is 1/3 to here. So this must be 2/3 here. This is 3/3 here. So A here is just equal to 2/3. And you can see it's 2/3 underneath here anyway. Let's have a look at B here, where we took out 1/9, 2/9, 3/9, 4, 5. This is 6/9 here, 7/9, 8/9, and this is 9/9. Right out the end here we've got 9/9. So this D here would have to be 8/9. C here is just 7/9. 6/9. There would be a 5/9 and a 4/9 here. These are not part of the Cantor set. So you've got 7, 6, 5, 4. This is 3/9, which is 1/3. So this is 2/9 here. So this here is 2/9. B is 2/9. Okay, so out along here then we have 27ths. So we just got to count them out. Let's see, this is 1, 2, this is 3 27ths. We'll have a 4, 5, 6, 7. So this E here is going to be 7 27ths. 7 27ths. 1, 2, 3, 4, 5, 6, 7 27ths. Out as far as here. 7. Now we just have one more to do, and that's here. Well, these are all 27, so if you imagine 1 here is going to be 27 27ths. So this point here would be 26, so F would be 25 27ths. 25 27ths, and that's it. They're all the letters that we were asked to identify. So let's just fill those in into our table down here. I just put those in here. So A then is 2/3. B was 2/9. C is 7/9. D is 8/9. E is 7/27, and F is 25/27. 25/27. Okay, that's it. Now let's just take this and move it up a little bit. Okay, we have to give a reason here why this sum here is a point in the Cantor set. Now, in order to do this, we have 1/3 minus 1/9 plus 1 over 27 minus 1 over 81. Really, we're just going back and forward through points on the Cantor set. So let's have a look at our original diagram again here. So what we're doing here is we're starting at 1/3, so we're starting here. We're going back 1/9. So if you imagine you take out the middle third here, so if you just imagine here that there's this B here, this 2/9 is here, we're going to go back 1/3. We're going to take out this middle third here. So there's going to be a point here in the Cantor set. So that's if we subtract 1/9. Then we're going to go forward 1/27. So this is our 27ths here. So from this segment here, then we're going to take out the middle segment here. So this point here is going to be in the Cantor set as well. And it's getting a little bit small here now, but that line segment there we're going to take out 1 over 81 as well. So just to go back here, if you actually do this sum here, you get 20 over 81. 20 over 81. Now this point is going to be on the Cantor set for the reason I said there. If you have let's take this point, this segment here, 0 to 1/3, and we'll just make it quite big. 0 to 1/3. So let's take 0 here, and we'll take 1/3 is going to be way out here. This is 0 and this is 1/3. We've got to take out the middle segment here, middle third. So we're going to take this bit here out and this bit here out here. So this will be 1/3 of 1/3. So this is going to be 1/9 here, and this is going to be 2/9 here. And so we're going to be removing this bit here. We're going to be removing this bit here. Now, after that, then what we're going to be doing, this is so we've gone out to plus 1/3. We've gone back 1/9. So we're actually here now. Now we've got to go up 1/27. So what we would end up doing here is taking out this bit here. So we're going to be taking out this bit here. So this point here is going to be bring us up to this segment here, I should say, is 1/27. So this point here is going to be on the Cantor set, and then we've got to go back 181. So in other words, we're going to take out this segment here. So this point here, this is where we're actually going to end up. This point here is 20 over 81. So this point is on the Cantor set. Okay, I'm just going to move on from that to the last, I think this is the last question anyway. Let's have a look. We have to find the limit of this series here, 1/3 minus 19 plus 127, and so it is a point on the Cantor set, and we've got to find this particular point. So let's just have a look at that. So the limit of this series is really just what we get when we add this series up into infinity. So what we really want to do here is get the sum to infinity of this series here. We're just going to use this a over 1 minus, or where a, and this is a geometric series in this case. So we've got 1 over 3 minus 1 over 9 plus 1 over 27 and so on. This is a geometric series where a is equal to 1/3, and again or here now is going to be equal to minus 1/3. So let me just double check that. If you multiply 1/3 by minus 1/3, you get minus 1/9. Multiply minus 1/9 by minus 1/3, you get plus 1 over 27 and so on. So this should work out. Okay, so we've got a is 1/3. We have 1 minus 1/3, so that'll give us 1/3 on the top, and here 1 plus 1/3, so that's 1 and 1/3 here. I'll just come over in this direction here. So we got 1/3. Here we got 3 1s. 3 and 1 is 4 over 3, so that'll give us 1/3 times 3 over 4, so that'll just give us 1/4 here. So the limit of this series is just simply 1/4. The limit of that series is 1/4. So that would be the point on the Cantor set. If you were to continuously do this into infinity, you would just get 1/4. Okay, so that's it for this particular question.